Hi, my name is Jocelyn Hargrove, and I'm a senior at the Neighborhood Academy. I am in the science section for senior seminar. Did you know that hair care products can affect more than just your hair? I recently learned that some personal care products contain endocrine disrupting chemicals, otherwise known as EDCs. They can affect the hormones in the body, leading to negative health issues. I use various hair care products and have yet to determine which works best for me. I would like to become a more informed consumer and know whether or not I should be avoiding certain products that are in my home. Hence, my project uses gas chromatography, mass spectrometry, or GCMS to detect the EDCs found in Black hair care products. What exactly is an EDC? By definition, it is an exogenous chemical or mixture of chemicals that interfere with any aspect of hormone action. Simply, it is an outside chemical that affects the working parts of the inside of the body, specifically the endocrine system. Some commonly known EDCs are BPA, parabens, PCBs, and lead. As shown in the figure, the endocrine system consists of glands and organs that use hormones to send messages to the glands. The system kind of works like a radio station. Some commonly known hormones are testosterone and estrogen. Some negative effects of EDCs are ovarian development issues. As you can see in this figure, BPA is a cause of the different stages of ovarian development issues. Another effect can be early menarche. Black girls start their period 0.06 years earlier than any other race. Another negative effect can be increased risk of breast cancer, fibroids, obesity, and preterm birth. A study that I reviewed that was done in 2018 by him and colleagues specifically looked at hair care products used by Black females to determine the measurement of endocrine disrupting and asthma-associated chemicals. What they did in the study was use 6 different categories, which were hair oil treatments, leave-in conditioners, root stimulators, hair lotions, and hair relaxers. There were 18 different products tested in each of those categories. They looked for 66 different chemicals. What they found were that 84% of the chemicals that were present in the product were not listed on the labels. Lower concentrations were only listed 8% of the time, and even higher concentrations were still only listed around half of the time. This chart shows the following. These are the categories of the chemicals being targeted. These are all the individual chemicals that were targeted. These were the commonly used hair products that were tested, which are unbranded. This is a heated colored key to show the levels of concentration the chemical produces in the product. The darker the color, the higher, and the lighter the color, the lower the concentration. Each of these chemicals that are being pointed out are the chemicals that I will be targeting in my study. I'm choosing these 3 chemicals because they hold the highest concentration of the 3 different categories of chemicals that tend to be found in most products. Diethyl phthalate, which is used as a solvent in fragrances, were found in 78% of hair products detected in the previous study. Methylparaben, which is used as a preservative in products, were found in 72% of the products in the previous study. And decamethylpentacyclosiloxane, which is used for spreadability in products, was found in 67% of products in the previous study. How I decided to pick my products were determining whether or not they were promoted towards Black women. And I used 3 different categories that Black women use, which are moisturizers, relaxers, and hair oils. I then went on to this website to find starting points. After that, I went to Sky's the Limit and Target in the section promoted towards Black women. These are the products that I decided to choose, and the black boxes represent the products that had listed chemicals on them. The gray boxes represent products that had nothing listed, and the white boxes represent the products that had free of a certain chemical. For preparation for the samples, I took 0.25 milliliters of the hair product and diluted it with 50 milliliters of a 3-to-1 dichloromethane methanol solvent and allowed it to dissolve for 6 minutes. I then transferred that into vials. 6 milliliters of the hair product solution was passed through the solid phase extraction cartridge. Because the technique of the GCMS is so sensitive, prior to analysis with GCMS, we needed to further dilute the samples. So I took 0.1 milliliters of my sample with a 1.5 milliliters of methanol and placed it into the vials. After being placed into the auto sampler, they were injected into the GCM column, which separates the component, and then entered the MS, and the components are then identified. This representative chromatograph shows a mixture of components that were separated. The software identifies the peaks with the greatest peak area, and then they compare it to the library of the software. The retention time for decamethylpentasiloxane was 7.75 minutes. Each peak on the chromatogram represents a substance, and the mass spectrum shows the breakdown of that substance. The breakdown of the substance is going to be the same every time, essentially creating a fingerprint for the software to be able to identify a specific chemical. In this figure, it shows which product had any detection of the chemicals being tested. The highlighted product, which is the argan oil relaxer kit, was unable to have the conditioner component tested due to the fact that while transferring through the solid phase extraction cartridge, it evaporated. In our detection, we were able to detect cyclosiloxane in 5 different products. Of the 5 products that detected cyclosiloxane, 2 of them were moisturizers, which were TGIN and Shea Moisture. 1 of them were hair oils, which was African Pride, and the other 2 were relaxers, which were Luster's Relaxer and Soft Sheen Relaxer. There were 4 different types of cyclosiloxane detected. The original one we were looking for was detected. 50% of the products contain cyclosiloxane, and in previous studies, it was shown to be found in 67%. In this figure, we have the detection of diethyl phthalate, which was unable to be detected due to the fact that the boiling point is 295 degrees Celsius, and in our method, we use the temperature of 240 degrees Celsius. In prior studies, it has been shown that 78% of products contain the product. So it was expected to be found in our study as well. The detection of methylparaben was also unable to be detected due to the fact that it was not tested because of the high boiling point as well. We were unable to do the derivatization that was needed, but it was also expected to be detected due to the fact that it is a common chemical, and in prior studies, it has been shown to be found in 72% of products. Some of our limitations were the argan oil relaxer kit conditioner not getting tested, the method we used, which stopped at 14 minutes, and due to the strength of the affinity, the chemical could have stuck to the column longer than 14 minutes. The method we used also, as stated already, set the temperature to 240 degrees. Something you can do in the future is create standards in order to measure the concentration of the chemical instead of just the detection. I would like to acknowledge Dr. Badger from RMU, Charlene Lewis, and Emmanuel George from Covestra, and Dr. Nutbrown. These are my references. Thank you.